Hi, welcome back to McClutchy Maths. My name is Natalie McClutchy. We are continuing our video series today on algebraic techniques. This is our 11th video and we are now getting into solving equations. We're going to start it fairly simple today by looking at one-step equations. So in this video we're going to talk about the notion of equivalence. We're going to look at something called inverse operations, some worked examples, and then talk about what's coming up. So firstly, this idea of equivalence. We get the word equivalence from the word equal. So you would recall from our previous video that an equation has three parts. We've got a left-hand side, a right-hand side, and that equal sign in the middle. And here's an example of what an equation might look like. So we've got our left-hand side over here, our right-hand side here, and our equal sign. It's left-hand and right-hand according to where the equal sign is. So that equal sign tells us that whatever is happening on that left-hand side, whatever 3x plus 7 adds up to, it could add up to 50, 400, 4 million, any amount at all, it's possible. Whatever 3x plus 7 is adding up to is going to be the same as adding up 5x plus 2. Now you might say to yourself, well, how is that even possible? How does 3x plus 7 equal 5x plus 2? They look like different things. If we think about it in terms of whole numbers, if I said 2 plus 2, well, that's equal to 4. I could say 2 plus 2 equals 4. That's an equation. Each side is equivalent. I could also say 2 plus 2 is equal to 3 plus 1. I could say 1 plus 3 equals 4 plus 0. There's lots of different ways of expressing that equivalence by different combinations of numbers being added or subtracted or multiplied by each other. And that's what we have in this equation here. We've got an unknown being added to a known and another different unknown being added to a different known. Two different combinations. They are going to be equal in amount to one another. And here we go with some more examples of those number combinations. 3 plus 7 being 10 equals 5 plus 5, which equals 6 plus 4, which equals 9 plus 1, and so on. So we can see that there are lots of different possible combinations, and we're just introducing letters into the mix. Now, it's really important when we think of equivalence, we could think of that like a set of balancing scales. Now, most of us are used to digital scales these days because we are in 2020s. So we're used to using digital scales. We just plonk something on top and it tells us how much it weighs. But in the olden days, we used to have something called a set of scales. You may not have ever seen these in real life. And what happens is you put weights on different sides and the scales tip in different directions depending on which side is the heaviest side. So we can think of our equation like two sides of a scale, with that middle post in the middle being our equal sign. So we can see that on the left hand side of our scales we've got 6 plus 4 and that's equal to 5 plus 5. So we've got these two sides of the scales and they are perfectly balanced at the moment because the equation is true. However, if we add or take away anything to either side of the scales, it's going to tip and get out of balance. So if I add 5 to the left-hand side of the equation, we can see straight away that that is going to be heavier now, and the scales are going to tip out of balance. So what we want to do, one of our rules about equations is we've always got to keep them true or in balance. They've got to be matching on both sides. If an equation becomes unbalanced or untrue, it's impossible to solve it. So we want to be able to solve our equations and work out what the value of our unknown letters are. And the way to do that is when we do things with equations, whatever we do to one side, this is our most important rule, we have to do it to both sides. If I'm going to add 5 to one side, I've got to add 5 to the other side, and that will keep our equation in balance. It will make our equation true. So what we're going to be doing throughout the next few videos, to solve equations, we sometimes have to do different things to the equation to manipulate the numbers and the letters around in order to try and get that letter that we're trying to solve for all by itself. And in order to do that, we do things to different sides of the equation. So that's our big rule. Whatever you do to one side, you must do to the other side. So to do that, we do something called inverse operations. So what we're trying to do here to solve that equation, we're trying to work out what that value of the letter is that makes the equation true. So in this particular example, we're trying to find the letter y, what its value is. Now we could use something called guess and check. Guess and check means I say let y be equal to 0 and I substitute it into the equation and test it and see if it works. Well, if we did that, 3 times 0 is 0 plus 7 gives me 7, not 15. So that's not true. Y cannot be 0. I could try that and keep trying until I get the right answer. Sometimes that works fairly quickly. Sometimes it takes a long time to get there. And it's not a super effective way of solving equations. And in fact, it's also not a method that many teachers will award marks for these days. So guess and check, yes, it is a valid method, but it's not the method we want to introduce you to. It's not a great method for advanced equation solving. So yes, we are trying to find the value of y. So what we do is something called inverse operations. Now the word inverse, we're going to get to what that means in a moment. We're going to get to what operation means in a moment. But what we're trying to do is work out what's happening to our letter at the moment. How do we then undo it? So I always ask a series of questions, and we'll get into those questions shortly. And to work out what's happening, we're then going to apply an inverse operation. Now, I know I sound like I'm talking a lot of mumbo jumbo. Have a look at this equation here. First of all, my first question I'm going to ask myself is, which side of the equation is the unknown on? What letter am I trying to find the answer for? It's a good question to ask yourself, just to get you to inspect the equation to start off with. So I'll start by saying to myself, I'm trying to find the value of y, and currently it's on the left hand side. So that's the first thing I want to know. The second thing I want to do is think about what is happening to y. Well, at the moment, 7's been added to y, and y has been multiplied by 3. So there are two things happening to y at the moment. It's been multiplied by something, and something's been added to it. So then what I'm going to do is undo the times 3, undo the plus 7. To do that, we apply that inverse operation, which means the opposite. So we're going to do the opposite of times 3 and the opposite of plus 7 to get y all by itself, which is the objective of solving equations. Now, whatever I do on that left-hand side where the 3y plus 7 is, if I add something or take it away, if I do an inverse operation or an opposite operation, I have to do it to the 15 as well. Remember, that's our very important rule. So there's two things we need to remember from this video. If you take away nothing else, take away two things. Firstly, whatever I do to the left-hand side or the right-hand side, I've got to do to the other side. And to get the letter all by itself, I have to undo what's happening to it by doing the opposite. So let's talk about what inverse operations are. Operations are plus, minus, times, divide. Okay, so firstly, the opposite of addition is subtraction, which means that the opposite of subtraction is addition. That's fairly straightforward to remember. The opposite of multiplication is division, and then the opposite of division is multiplication. So anytime you see a number added to a letter, to undo that add, we do the opposite, which is we subtract that number. If we see a number multiplied by a letter, to undo that multiply, we divide by that number. And our last one here is powers. Now, we're not going to talk about powers for the first few videos, but later on we're going to. Important thing to keep in the back of your mind is that the opposite of squaring something is to find the square root, and the opposite of square root is to square. We'll talk about that later. Okay, let's look at some 4 simple examples. These are 4 one-step equations. The reason I've chosen 4 worked examples is because we've got addition, subtraction, multiplication, and division that we're going to talk about. So I'm going to show you how to solve 4 of these ones using opposite or inverse operations. So we could do this first one by inspection. M plus 4 equals 9. So what I mean by inspection is, this is my first method. I could just use my number facts and simply ask myself, if I add a number to 4, what number would I have to add to make 9? Now, most of you could take the number 4 and then count on 5, 6, 7, 8, 9. And you've worked out that you have to add 5 on. So you could do it that way, or you could use your ruler and count on to 9. Some of us know these number facts in our head off by heart. What number do I have to add to 4? 4 plus 5 makes 9. That's the first method. Now, for one-step equations, it's a valid method and it's a very quick method if you're good with your number facts. However, once we get to two-step equations, using this method becomes very difficult. So that's why I'm going to teach you a different method today. We're going to focus on this method as our primary way of solving equations right through to our more complex equations. So we're going to ask ourselves the questions. So here is question 1. What's the variable we're trying to solve for? So what letter are we trying to work out? We're trying to work out what the letter M is. What's its value? Question 2, what side of the equation is M on? You can see here it's on the left-hand side. Now you might think, why do I need to ask that question? Later on, you're going to find equations with it on both sides or on the right-hand side. It's good to work out which side it's on so you know where you're trying to head. Question 3, what is happening at the moment to the variable M? Well, 4 is being added to it. So what is the opposite of adding? Subtraction, or take away, or minus. So now if I know I've got 4 added to the left-hand side, to undo it, I need to subtract 4 from both sides. So you can see I've subtracted 4 from here, and I'm going to subtract 4 from here, because whatever I do to one side of the equation, I do to the other. Now, there's different ways of showing the working for this. I always like to layer it. So I like to put what I'm doing underneath. Some students write it off to one side. Some students also write it off in the middle here. They might do +4, -4, and then -4 here. But when I see students do the +4, -4 method, I sometimes see them then add 4 and -4 here and get a little bit confused. That's why I like to layer it on top of the other. Your teacher may have shown you a different method, and it's fine as long as you're showing you're working. And this is why I like this method too, as opposed to just working it out in your head, because often you're expected to show working, and this is the working that gets you the full marks. So what I've done here, now I'm going to be working in columns. So if I look down now, well, M plus no other M's or minus any other M's is just M. +4, take away 4 gives me 0. So I'm left with just M on the left-hand side of the equation. Now if I work down on the right-hand side, 9 take away 4 gives me 5. So I'm left with M equals 5. That's why I like this method, because it works like a sum that you can work down. And you're basically working down, and whatever you're left over with on this side, M +4 -4 is just M. 9 take away 4 is just 5. So that was our first worked example. Worked example 2 is also a one-step equation, but this time it's a little bit different. We've got subtraction. Once again, you could use your number facts and ask yourself what number less 2 or take away 2 is going to give you 15. And if you can work that out in your head, you would know it's x equals 17. However, I want you to get good at asking yourself the questions. So the first question is, what letter are you trying to solve for? What's the variable? It's the letter x. And what side is it on? It's on the left-hand side. What's happening to x at the moment? This is probably a really important question to ask yourself, because this will help you work out what to undo. At the moment, 2 is subtracted from the x. So what do we do to undo take away 2? What's the opposite? We're adding 2. So now let's set it up. We've got x take away 2 equals 15. So we know we need to add 2 to both sides. This is the important part of both sides. So notice I've put it underneath the take away 2 and underneath the 15. So now I'm going to work in a column again. I've only got one x on this side. Nothing else happens to the x because there's no other like terms on that side with the x. So x will come down here. Now I've got -2 plus 2 takes me to 0. So I've cancelled this out effectively. It's gone away. And on this side, 15 plus 2 gives me 17. And that should say x equals 17. You can see I copied and pasted slides. Okay, worked example 3. Solve 5f equals 30. So once again, yes, you could use your number fact. If you're good with your times tables, you could simply say to yourself, 5 times what is equal to 30? And you might count on 5, 10, 15, 20, 25, 30 and work out that f equals 6. So that might be one quick method of doing it. Have a look at your question. How many marks is it worth? You may not. It might be a very quick one for you to quickly solve without showing working. But if your teacher is expecting working, then you need to show working. And that's where method 2 is better, using the inverse operation. So let's start again. What letter are we trying to solve for? We're trying to solve for f. Which side of the equation is it on? It's on the left-hand side. And what's currently happening? And this is probably, like I said before, the most important question, because this helps you work out what you need to do, which is opposite. So what is happening to f at the moment? It's being times by 5. And how do I undo multiply? What's the opposite? It is divide. So I'm going to be dividing both sides by 5 to solve. So I'm going to write it out again. 5f equals 30. I'm going to put a divider by 5 on the left and a divider by 5 on the right. Now this is where a lot of students then don't know what to do next, because I do see some students write the next answer as 5f equals 6. 5 divided by 5 is equal to 1. So 5f divided by 5 is equal to 1f, or just f. equals 30 divided by 5, which is 6. Last example, we're almost there. Solve j over 3 equals 8. So we've got a bit of a fraction going on here. But remember, when we've got a fraction, this symbol here means divided by. Now, I'm not going to do this particular question using method 1 because now we're starting to get a little bit more complex. And as soon as people often see fractions, they do get a little bit anxious. So we're going to move straight to method 2. Using those inverse operations. So let's start by asking ourselves some questions before we have a panic. Okay, so what's our letter? It's J. What side is J on? Well, it's on the left-hand side, but it's on numerator of a fraction. It's on the left-hand side. So what is happening at the moment? You might write down, well, it's part of a fraction, but think about that a bit further. A fraction means numerator divided by. This symbol here means divided by denominator. So it's divided by 3. How do I undo division? Multiply. Okay, so now instead of panicking about fractions, I'm simply doing opposites. That means I've got to multiply both sides by 3 to solve this. So what I'm going to do is rewrite this. And notice how here I've put a little bit of a gap. Okay, and the reason for that's going to become apparent in a moment because I'm going to be multiplying this fraction by 3 and then multiplying the other fraction by 3. Now here's where fraction rules are important. Now that this 3 forms part of the numerator, 3 times j is just 3j. 3 divided by 3 is 1, because anything divided by itself is always 1. So I'm left with 1j. Effectively, you might see people doing crossing out. I can cross out the 3 divided by the 3 because it becomes 1. So I could actually cancel those two and just have a j by itself. J is going to be equal to 24. Now, we haven't talked a lot about checking our work. It's a really good idea at the very end of every one of these worked examples, when you've got a solution, when you've solved the problem, you've found the answer for the variable j equals 24, to then substitute it back in, which means put it back into the equation. 24 divided by 3 is the answer 8. And if it's true, you know you've solved correctly. Okay, well, let's have a quick talk about what's coming up and then how we can engage further with McClutchy Maths. We're going to be doing lots more solving over the coming videos. We're going to be looking at two-step equations, equations with letters on both sides of the equal sign. We're going to look at powers and square roots and some more difficult stuff going on there. Then we're going to move into index laws and then into some algebraic fractions. The series isn't going to finish there though. We've got quadratics coming up as well as polynomials and more senior mathematics. Did you find the video helpful? If this was helpful for you to get a process together for solving equations, forming an important foundation for later mathematics, here are some ways you can engage. You can like and subscribe and hit that notifications button so you'll know when our next video is available to watch. Add your thoughts in the comments and follow us on Facebook and Instagram. And if you've got any questions, contact me at mcclutchymaths@yahoo.com. And I'd like to say a big welcome to some of our new subscribers this month. Thank you very much for joining us. We really appreciate your contributions to the channel. Well, I'm Natalie McClutchy. Have a wonderful day.